Hey Pre-Calc! In this video we're going to be talking about section 2.2 day 1, polynomial functions. We're going to focus on the leading term test and end behavior. And you should also be able to graph monomial functions. So what is a polynomial function? It is the sums and differences of monomial functions. And monomial, remember, just means one, so like just x squared or x to the fifth, just one term. From other types, form other types of polynomial functions. Right, so quadratic is a polynomial function made up of three monomial functions, right? X squared, x, and a constant. The leading coefficient, which is incredibly important, the leading coefficient of a polynomial is the coefficient of the variable with the greatest exponent. It was with into the one sentence. With the greatest exponent. Okay. Now let's talk about the leading term test. You learned this all last year. So far it's just review. So the leading term test uses the power and coefficient of this term the leading term, to determine the polynomial's end behavior. So leading term is usually written in the very, very front. That's why it's called the leading term, but sometimes it could be in a mixed up order. Okay, so D is going to represent degree in this example. And then LC is going to be leading coefficient. So for end behavior, I'm going to do each scenario. On a graph. And the idea is you won't have to graph these, you're just going to look at the degree and the leading coefficient. We'll just do a little sketch. Okay, so there are 4 different ways your end behavior can be, right? As x approaches negative infinity, it could be going towards positive infinity. And positive infinity. Please don't connect these, this is just the ends. Right? It could be going towards negative infinity and negative infinity. It could go towards positive and negative infinity, or negative infinity, positive infinity. So there's 4 different kinds of end behaviors your polynomials will have. So in order for them to both be positive, your degree would be even, and your leading coefficient would be positive. In order for them to both be going down toward negative infinity, your degree would be odd, and your leading coefficient negative, which makes sense because it would be reflected over the x-axis. Here, to end going negative, it would be, so opposite directions is just odd. Sorry, I messed up right here. Same direction means it's even, like x squared, right, goes in the same direction. I don't know why I wrote odd. So if it's odd, they're going in opposite directions, and if it's ending going down, that means the leading coefficient was negative. And if it ends going up, that means your leading coefficient was positive. So the way we write our end behavior is just like we did back in chapter 1. So you'll be using limit notation. So let's just do an example. Describe the end behavior of the polynomial using limits and explain your reasoning using the leading term test. So I guess we can do a couple examples. First example, g of x equals 4x to the 5th minus 8x cubed plus 20. So be careful here. It is in order, going from greatest exponent to lowest exponent. That doesn't always happen though. So this is our leading term. So for the leading term test, we need to determine what is the degree and what is the leading coefficient. So required is obviously, well, maybe not obvious, but is determining these. So what is the degree? So 5 is the degree here. And what is the leading coefficient? The leading coefficient is 4. So you need to show your work here. Optional is like you could either do this in your head or physically write it down. So 5 is odd and 4 is positive. So that means in my head, opposite directions, but I'm ending on a positive note. So now I just need to write what my end behavior is. So so the limit as x is approaching positive infinity, it's not f of x, it's g of x. G of x, the function, is going towards positive infinity. And then the end behavior as x is approaching negative infinity of g of x, right? As we go to the left, it's going to be going down, so it's going to be going towards negative infinity. And then we're done. So you don't actually have to graph it. So everything I've done in green is required. You have to let me know the degree, and I guess you would need to write this out too. So let's do one more example. Let's call this h of x equals, 2x squared minus 2x to the 6th plus 11x to the 4th. So this isn't how you would write a polynomial if you were like writing the equation of the graph for yourself. You would write it from the leading coefficient first in descending order. So be careful. So common mistake is to say that this is the leading term, but it's not, because the term is determined by the highest degree. So this should be the leading term. So required work, what is the degree? What is the leading coefficient? So the degree here is 6. The leading coefficient is -2. So again, you can either physically write this out or do this in your head. I like to write it out. I think it's helpful. So this degree is even, so that should make me think, okay, same direction. -2, so this is negative, so that means my function will be facing downward completely. And the reason we leave the space in between is because we don't know how many turning points there are. We're not actually graphing this. We'll talk about that another day. So now I need to write out my end behavior. So the limit as x is approaching positive infinity of h of x, we are going towards negative infinity. And the limit as x approaches negative infinity of h of x is also going to negative infinity. So technically you could have written one statement and said plus or minus. Okay. All right, and then one last thing just to take note of, graphs of monomial functions, because your homework is going to ask you to graph. I'm going to just try to fit it all in. So these aren't monomials, right? Because like this has 3 terms, this has 3 terms. Monomial is just like x squared, x to the 5th, 7, x to the 5th minus 1. So graphs of monomials are actually quite easy to graph. So if it's an even degree, non-constant, monomial, it resembles the graph of f of x equals x squared. So I'm saying like if it's just 2x squared or 2x to the 4th or x to the 8th, they're all going to look very similar to a quadratic. It's just going to be like a little bit wider. So you can play around on your graphing calculator to see what it looks like. And then odd degree resembles f of x equals x cubed. But again, it's like kind of like longer, like the flattening out part is a little bit longer. So you use the basic shape and the characteristics of what you know about x squared and x cubed, and then what you know about transformations to graph these. And then we'll talk about other polynomial graphs in our next video.